Very good morning. Today I will be doing the question number 9 of exercise 1.3. The question number 9 of 1.3 states that f is a function from positive real number to minus 5 to infinity and is defined as f of x is equal to 9x square plus 6x plus 5. Now we have to prove that it is an invertible function, so that f is invertible and its inverse function is defined as f inverse of y is equal to under root y plus 6 minus 1 upon 3. Right. Now since we have to prove it is invertible or not, first of all we will prove it for 1 1. For 1 1, let x1 comma x2 belongs to the domain of this given function, that is r plus positive real number. Now such that f of x1 is equal to f of x2. F of x1 I will get now 9x1 whole square plus 6x1 minus 5 is equal to 9x2 whole square plus 6x2 minus 5. Minus 5 and minus 5 is cancelled from both the sides. Can write as 9x1 square minus 9x2 whole square plus 6x1 minus 6x2 equal to 0. Can I have common here 9? 9x1 whole square minus x2 whole square plus 6x1 minus x2 equal to 0. Now x1 minus x1 whole square minus x2 whole square, I can write x1 minus x2 and x1 plus x2. Here we also have x1 minus x2. Can I have common x1 minus x2? Now I am left out with 9 x1 plus x2 9 x1 plus x2 plus 6 equal to 0. Now the second part, product of these two parts is equal to 0. The second part cannot be equal to 0. That's why the first part is equal to 0. That means x1 minus x2 equal to 0. And it implies that x1 is equal to x2. What you have taken, f of x1 is equal to f of x2, and I am getting now x1 is equal to x2, and hence it is 1 1. Right? Now you prove it that it is onto also. For onto, we take y belongs to codomain of f. For onto, let y belongs to codomain of f. Codomain of f, right? Such that x belongs to the domain of f. Such that x belongs to codomain of f. Now y is equal to f of x is equal to 9x square plus 6x plus minus 5. Here y is in terms of x. Now I have to write x in terms of y. Now y is equal to, this can I write 3x whole square plus 2 into 3x into 1, so that I get 6x plus 1 minus 6. See, plus 1 minus 6, it will be 5. Now why I have done this? Because it becomes a perfect square. 3x plus 1 whole square minus 6, which I can write 3x plus 1 whole square is equal to y plus 6, right? And therefore 3x plus 1 is equal to under root y plus 6, and therefore I can write x is equal to under root y plus 6 minus 1 upon 3. X is equal to 3x is equal to under root y plus 6 minus 1. and after that I write x is equal to under root y plus 6 minus 1 is equal to 3. And this function again y plus 6, under root y plus 6 is defined only when the value of y is what? More than minus 5. Then only it is possible. That's why for every x, for every y belongs to codomain of f, there exists a unique preimage in the domain of f, and hence it is onto. And here x is equal to under root y plus, and hence it is onto, and it x can be written as, I'll go for the next part, x is equal to this, therefore we know that y is equal to f of x. Here x is equal to under root y plus 6 minus 1 upon 3, and y is equal to f of x gives what? F inverse of y is equal to x. Therefore what will write? F inverse of y is equal to under root y plus 6 minus 1 upon 3, or I'll write its inverse function is given by g of y is equal to under root y plus 6 minus 1 by 3, right? And now I have to prove, the second part I have to prove it is invertible. It is invertible. For invertible, what I have to prove? I have to find out f of g of x and g of f of x, right? Fine. Can you write it now? F of x is 9x squared plus 6x minus 5, and g of y we have discussed as under root y plus 6 minus 1 upon 3, isn't it? Okay. Now f of x is this and g of y this. Now f of g of x or g of f of x. G of f of x. We'll go for g. Now the second part. G of f of x. We'll write g of f of x. G of f of x is what? 9x square plus 6x minus 5. And now g of x, g of y is under root y plus 6 minus 1. That's why this will become what? Under root. In place of this I write 9x square plus 6x minus 5 plus 6 minus 1 upon 3. This will give you what? Under root 9x squared plus 6x plus 1 minus 1 divided by 3, which will give you what? Under root 3x plus 1 whole square minus 1 upon 3. That will give you what? 3x plus 1 minus 1 upon 3. Minus 1 plus 1 cancel. 3 and 3 is cancelled, and getting x. G of f of x is equal to x. G of f of x is equal to x. If you remember, when I discussed the invertible function, we have to that g of f of x is equal to IA, f of g of f is equal to IB. That is identity functions. If I put here x, I am getting x over here only, right? Therefore, g of f of x is equal to x. Now I will find out f of g of y I will go for it, right? Now f of g of y, that is equal to f of g of y is equal to what? Under root y plus 6 minus 1 upon 3. And f of this is equal to what? F of this is equal to 9x squared. So now I write here 9 in bracket under root y plus 6 minus 1 upon 3 whole square 9x square plus 6x. In place of x I write under root y plus 6 minus 1 upon 3 and minus 5. Right? Now under root y plus 6 minus 1 upon 3 whole square. Can I remove this 9 and this 3 whole square I can remove? Now under root y plus 6 minus 1 whole square, if I square it, I will get what? Y plus 6 under root y plus 6 whole square plus 1 whole square minus 2 under root y plus 6 plus. This part is done. Now the second part, 3 2 ja 6. Now 2 under root y plus 6 minus 2 minus 5. See now, plus 2 under root y plus 6 minus 2 under root y plus 6 is cancelled. Now I'll get here y plus 6 plus 1 minus 2 minus 5, and that will give you y. Now see, f of g of y is equal to y, right? Therefore it is an invertible function, and its inverse is defined as f inverse of y or gy is equal to under root y plus 6 minus 1 upon 3 and hence proved. Fine. See, almost the questions of the NCERT I have done, and now there are some questions which you have to do. Now I will be doing some of the questions which have been asked in the examinations, either 1 mark questions, 2 mark questions or 4 mark questions. I will do another 3-4 questions. Right, now I have done 3 questions right now on the board. The first question is, if r is equal to xy such that x plus 2y is equal to 8 is a relation on n, then write the range of r. The second question is, let r is equal to a comma aq such that a is a prime number and this prime number is less than 5, then find the range of r. Third question is, if function is defined as from real number to real number and f of x is equal to 3x plus 2, then find f of x. Right. First question, that xy such that x plus 2y is equal to 8. See, we can have take any number of x. If I take x is equal to 1, then I will get 2y is equal to 8 minus 1, 7. 2y is equal to 7 and y is equal to 7 by 2, which is not a natural number. That's why I will not take the value of x as 1. If I take the value of x as 2, then I will get what? 2y is equal to 8 minus 2, 6. Right? And therefore y will be 3. That means the first ordered pair which will be having, that will be what? That means the r is equal to, what we will get, which is the condition, 2, when x is 2, y is 3. Similarly, can we have any other pair? If I take 3, it cannot be. If I take 4, so now if I take 4, then 4 plus 2y is equal to 8, the 2y is equal to 4, 2y is equal to 4, y will be how much? 2. Therefore, the second pair of this will be what? 4 comma 2. 4 comma 2. Can we have the value of x 5? No. If I take x is equal to 5, I will get 2y is equal to 8 minus 5, that is 3. Again, y will get 3 over 1, 2. No. Therefore, I will get 6. If I take 6, x is equal to 6, then 2y is equal to 2 and y will be 1. The relation defined as x plus 2y is equal to 8 has the ordered pair 2, 3, 4, 2, 6, 1. Now it is very easy to find out its range. Therefore, the range of R is given as what? 3, 2, 1, or I can write 1, 2, 3. That is the answer. Right. Now the second question. R is equal to AQ, where A is a prime number less than 5. Tell me all the prime numbers which is less than 5. The first prime number is 2. The second prime number is 3. There are only 2 prime numbers. That means prime number less than 5. Prime number less than 5 is 2 and 3. That's why in this relation R we have R is equal to the ordered pair. I'll get 2 and 2 cube 8 and 3 and 3 cube 27. Only 2 ordered pair will have. That's why its range of given R is 8 and 27. Fine. Now the third question. F is defined as f of x is equal to 3x plus 2. Then you have to find out f of x. The third f of x is given as 3x plus 2. f of x is equal to first f of x 3x plus 2. Then I'll write right now f of 3x plus 2. f of 3x plus 2. f of 3x plus 2 will what? 3 into 3x plus 2 plus 2, can I write? This will be how much? 3 to the 9x plus 6 plus 2, that is 9x plus 8 is the answer. Right? Similarly, I'll give another 3, 4 questions. Now this is another question I have written on the board. If the function f from real number to real number r is given by f of x is equal to x square plus 2 and another function g from real number r to r such that g of x is equal to x upon x plus 1, then find FOG, GOF, and hence find FOG of 2 and GOF of minus 3. So the first part, FOG of x we have to find out. Solution. See, f of x is given as x square plus 2 and g of x is given as x upon x plus 1, where x is not equal to minus 1, of course. Now FOG of x is equal to f of g of x is equal to f of g of x is equal to x upon x plus 1. Now f of x is equal to what? X square plus 2. So now x upon x plus 1 whole square plus 2. This will give you x squared by x squared plus 2x plus 1 plus 2 by 1. Again, the LCM will have here x plus square plus 2x plus 1. Here x square plus 2x square plus 2 to the 4x plus 2. That will give you 3x square plus 4x plus 2 whole divided by x plus 1 whole square you can write, or x square plus 2x plus 1 is your choice. This is f of g of x, right? Now you have to find out g of f of x. Now g of f of x is equal to g. F of x is equal to what? X square plus 2. X square plus 2. Now g of x is equal to x upon x plus 1. Then what will get now? X square plus 2 whole divided by x square plus 2 x square plus 2, right? G of x is equal to x upon x plus 1. So x square plus 2 plus 1. So now x square plus 2 upon x square plus 3. This is the value of g of f of x. Now the second part of the question is, you are asked to find the f of g of 2. So now f of g of 2 I will put here. Therefore, f of g of 2 can I put directly over here? So now in f of g of 2 I have to find out, and f of g of x is 3x square. So now I will let 3 into, in place of x, 2 whole square plus 4 into 2 plus 2 whole divided by 2 whole square plus 2 into 2 plus 1. This will give it 4 3 is 12 plus 8 plus 2 by 4 plus 4 plus 1. 4 plus 4 plus 1. 22 by 9. This is the value of f of g of 2. F of g of 2 is 22 by 9. No?
Yes.
Right? Now you have to find g of f of minus 3. G of f of x is equal to x square by 2 upon x square plus 3. Now g of f of minus 3. G of f of minus 3. G of f of x is equal to x square plus 2 upon x square plus 3, and therefore g of f of minus 3 is equal to minus 3 whole square plus 2 upon minus 3 whole square plus 3. That is 9 plus 2 upon 9 plus 3. That is 11 by 12. Okay, can you find out g of f of minus 3 by another way? Suppose if you are not asked to find out g of f of x and f of g of x, and you are simply, two functions are given to you, f of x and g of x, and you are asked to find out f of g of f of minus 2, g of f of 2 or 3. Can you find it? Yes. We will start like this. Can I go for it? Suppose I have to prove that. Suppose I find g of f of minus 3 or f of g of 2. F of g of 2. Let us see now. F of g of 2. F of g of 2 I have to find out. Now first I will find f of g of 2. Now tell me f of g of 2. G of 2 is 2 upon 2 plus 1. 2 upon 2 plus 1. That means f of 2 upon 3. Right? And f of x is equal to what? 2 by 3 whole square plus 2. That means 2 to the 4 by 9 plus 2. Now 4 plus 18 by 9, 22 by 9. Both the way we can do it. See, I have done this question without finding f of g of x. Isn't it? If this question is asked to you in 1 marks, then simply you go for this way. Otherwise, if you are asked to find out g of f of x or f of g of x, first you find it out. Right? Now the fifth and the last question of today's revision. This fifth question has been asked in this year board examination also. So that the function f defined as from defined from f of x is equal to f of defined as function defined as f of x is equal to 4x minus 3 4x plus 3 upon 6x plus 4 4x plus 3 upon 6x minus 4 is 1 1 here minus is 1 1 and hence 1 1 onto 1 1 and onto and hence find its f inverse, right? So that the given function f defined as f of x is equal to 4x plus 3 upon 6x minus 4 is 1 1 and onto and hence find inverse, right? Now you know that for 1 1 let x1 comma x2 belongs to the given function f such that f of x1 is equal to f of x2. Now f of x1 is equal to f of x2, that is what? 4x1 plus 3 upon 6x1 minus 4 is equal to 4x2 plus 3 upon 6x2 minus 4. Right? 4x1 plus 3 upon 6x1 minus 4 is equal to 4x2 plus 3 upon 6x2 minus 4. It implies that 4x1 plus 3 multiplied by 6x2 minus 4 is equal to 4x2 plus 3 multiplied by 6x1 minus 4. It implies that 4x1, 6x2, 24x1, x2 minus 16x1 plus 18x2 minus 12 is equal to 4x2, 6x1, 24x1, x2 minus 16x2 plus 18x1 minus 12. Minus 12 is cancelled. 24x1, x2, 24x1, x2 is cancelled. Minus 16x1 and there on the right hand side we have plus 18x1. It implies that minus 16x1 minus 18x1 is equal to minus 16x2 and this x2 will take it on the right hand side minus 18x2. It implies that 34 minus 34x1 is equal to minus 34x2. Minus 34 is cancelled and it implies that x1 is equal to x2 and hence it is 1 1. Right? Yes. Now we'll prove it is onto. Now the second part for onto. Let y belongs to codomain of f, right? And therefore y is equal to f of x is equal to 4x plus 3 upon 6x minus 4. That means y is equal to 4x plus 3 upon 6x minus 4, which will give you 6xy minus 4y is equal to 4x plus 3. Right? Now 6xy minus 4y is equal to 4x plus 3. Here y in terms of x. Now you have to write x in terms of y. What you can do now, 6xy, it implies that 6xy, right, minus 4y is equal to 4x plus 3. Can I have this? I have to eliminate what? X. So now 6xy and 4x is there. So now I can write 6xy minus 4x is equal to 3 plus 4y. 6xy minus 4x is equal to 3 plus 4y. Can I have common here? X. Now if I take here 2x common, 2x I will take common. If I take 2x common, I will get 3y minus 2. 2 2 is 4x, 2 3 is 6xy is equal to 3 plus 4y. It implies that 2x is equal to 3 plus 4y upon 3y minus 2. 2x is equal to 3 plus 4y upon 3y minus 2, and therefore it implies that x is equal to 3 plus 4y whole divided by 2 will come here 6y minus 4. Can I write now? 2 3 is 6 minus 2 2 is 4. Now x is equal to 3 plus 4y upon 6y minus 4. Here x is equal to 3 plus 4y upon 6y minus 4. That means for every x belongs to domain of f. Right. Therefore what will I write now? For every y belongs to codomain of f, there exists a unique x or pre-image in the domain of f, and hence it is onto. Now its inverse function, x is given by its inverse function, and its inverse function, see here, x is equal to 3 plus 4y whole divided by 6y minus 4. Therefore its inverse function is given by f inverse of y is equal to 3 plus 4y upon 6y minus 4. I think it is clear for all of you how and why I am writing x is equal to f inverse of y. Just for names, y is equal to f of x. Now x is equal to f inverse of y. This f inverse of y is sometimes written g of y, isn't it? Inverse function. Please don't forget this part. Now its inverse, and therefore its inverse function, its inverse is given by f inverse of y is equal to 3 plus 4y upon 6y minus 4. Now you find out what? F of g of x and g of f of x, right? And that I hope that you can do it. Now this is almost, I have completed the relation and function. And now in my next lesson I am going to start with the inverse trigonometric functions, ITF, inverse trigonometric functions. And for that chapter it is very important to remember all the formulae which we have learned in class 11th, especially the formula related with sine 2x, cos 2x, sine 3x, cos 3x, sine x, cos x, tan x plus y, cot x plus y, sine a plus b and cos a plus b. Please go through the formula, right, so that it will be easy to understand. Well, I will start with the inverse trigonometric functions. Thank you very much for today's lessons. Now in the next lesson I am going to start with inverse trigonometric functions.